All right, today's lesson is going to discuss some topics from chapter 0 of the textbook on the fundamentals of chemistry, things like significant figures and units and that sort of thing. All right, before we get started with that, I do want to go over two concepts. The first is Bloom's taxonomy. And Bloom's taxonomy is a way of kind of describing how people learn. So at the base of the triangle, this is kind of the most basic level of understanding a topic. Here you're just asked to remember things, recall facts and basic concepts. Here's where you would be memorizing things um, and kind of just doing basic definitions. And again, this is fundamental to all the subsequent levels, but at this lowest level, there's not a high level of understanding here. But as you move up the triangle, we get toward the next level, which is understanding. And so all of those facts and basic concepts that we did on the first level of remembering, here's where we need to describe things a little bit more, discuss them, explain them a lot more. So it's taking these basic facts to the next level. And then as you continue to go up, the next level would be application, where you can take these facts and ideas and we can use that information in new situations. Now in a course like general chemistry, we're really going to be sticking toward the bottom 2 or 3 levels of Bloom's taxonomy. But as you go up in any major level of study, as you go to 200, 300, 400 level courses, you're asked to do less of the remembering and more of the analyzing, evaluating, and ultimately creating. And so again, when you're learning the chemistry, you need to try to go through all the different levels. It's not just memorizing a bunch of facts and formulas and things on the periodic table, but we got to use those and understand them and then go on and apply them. Now in the laboratory course, we have something called the inquiry wheel. And you're probably familiar with the scientific method, where you start out with posing a question and coming up with a hypothesis. And that's a very linear understanding of the process of science. But in reality, all of our laboratory investigations and even a lot of stuff we'll be doing in lecture is really more of a circular idea where we can start at any of these different points. Everything does begin with questions though. And so in our laboratory course, we do what's called the science writing heuristic, where we begin with a question and then we start formulating some ideas. How might we answer this question? What would an experiment look like? We're carrying out the experiment, collecting data, making claims, reflecting on the findings, and ultimately communicating. But the process never stops. You never come to the end. There's always going to be additional questions that are going to get asked. All right, now in terms of the material in chapter 0, a lot of these are fundamentals. The first thing has to do with the types of units we'll be working with. We use the SI units of measure, and so each type of physical quantity, whether it be mass, length, temperature, time, has a particular unit that's used with that. And then within those units, there are different prefixes that are going to be used in order to make those units bigger or smaller. For example, mass, the standard unit is the kilogram. But there are many other units that are based on mass. And so if you think about, here is the prefix kilo, which refers to 1,000 grams. So a kilogram is 1,000 grams. And so you see how as you go up the list, you're adding more zeros. And as you go down the list, you're adding more zeros past the decimal point. And so they get smaller here. Now we're not going to be using all of these units. The ones here that are mentioned in red, these are the ones that are used more frequently, but you need to have a basic understanding of what these different prefixes mean in terms of the power of 10 for them. All right, the next concept we're going to be talking about is accuracy and precision. So accuracy refers to how close to the true value is a set of data. Precision refers to how close are the values to each other. Now, one way of looking at this, one way that it's presented, is much like a target here. Whereas in target A, we notice that all three of the darts are very close together. And so this would represent a precise set of darts. However, those darts are not very accurate here. So not accurate. All right, so in B, we have the three darts are all close together. So they are precise. And they are in the middle of the target. So they are also accurate. And in C, you notice that the darts are not precise, nor accurate. It's a lot more random. So basically, this kind of helps you with the definition here. But in the chemistry lab, we're not throwing darts at a dartboard. So a better way of looking at this is looking at how we measure mass in the lab. So let's say, for example, I want to get the mass of a tennis ball. All right, now, I have three different instruments I can use in order to get that mass. All right, I've got a bathroom scale, a lab balance, and an analytical balance. You'll see that the biggest difference is, well, how many places past the decimal point do each of these go? All right, so if I go into Walmart, I can get a bathroom scale for maybe 10 bucks. And what we'll notice is if I take that tennis ball and I put it on that bathroom scale, I'll do it 3 different times, and I want to take an average of my measurements. And what we'll see here is that the tennis ball gives 2 measurements of around 0.1 kilograms and 1 measure of 0 kilograms. Now, obviously, that tennis ball has mass, so the idea of it being 0 is not correct. It's just that the bathroom scale is not engineered to measure the mass of something like a tennis ball. A bathroom scale is typically measuring things that are higher in mass. And so when you look at each of these, none of these are going to be close to the true value, we'll see is around 54 grams. And these are not precise. Right? There's not a high level of precision on a bathroom scale. Nor is someone who is purchasing a bathroom scale looking to get their mass down to fractions of a gram. It's just not the appropriate measuring device. If we go to a lab balance, right, and so some of these lab balances you can get for under $100 that will go to 1/10 of a gram. And so here we have 3 measurements that are all getting much closer to the true value. There is a little bit of difference between these measurements, so these are not super precise, but we're getting more accurate than the bathroom scale. When we go to an analytical balance, right, and especially one that goes out 4 decimal places, now you have quite a bit of an expense here, multiple hundreds of dollars. And you'll see here that now these values are identical until you get out to that 4th decimal place. So in this case, the analytical balance is adding a higher level of precision than the lab balance is. It is still accurate. Both of these last two are accurate, but with the analytical balance, you're paying for that higher level of precision. And so that's a better way of looking at accuracy of precision in the lab. All right, significant figures. Let's just kind of review some of the rules here. Now in this course, once we get beyond the first chapter or so, I'm not going to be super particular about significant figures other than when I'm testing or quizzing you on it specifically, just so long as you use a reasonable number and you just try to use best practices for this. But we do need to go over the tried and true rules here. And so the first says this: non-zero integers that are given in a value are always significant. We're always going to count them. All right, leading zeros. These are zeros that are going to precede the non-zero digits, but those do not count as significant figures. For example, here, these two digits right here, these zeros simply indicate the position of the decimal point. The only significant figures are the 2 and the 5 in this case. All right, so leading zeros are not significant. Zeros between non-zero digits are significant. So here you have the 2 zeros that are between the 1 and the 8. Those do count as significant. So this one has 4 total significant figures. All right, trailing zeros are going to be significant if the number contains a decimal point. The number 100 only has one significant figure. Now, there used to be a notation, I don't know that it's used very much anymore, where you would put a line over a trailing zero to indicate that it is significant. What's better is to use scientific notation here. And so if you have a number that contains a decimal point and you're making a point of putting these 2 zeros here, that's indicating that these are significant. And so this number here has 3 significant figures. All right, exact numbers are ones that are determined by counting, not by using some kind of a measuring device. Exact numbers are said to have an infinite number of significant figures. So for example, if I were to count 10 people, 10 people is an exact number. It has infinite significant figures. Money and currency, you don't have fractions of cents. I can count out pennies specifically. So $1.99 represents 199 pennies. I can count those exactly. And so again, most currency is going to have infinite number of significant figures. And then there are some definitions. So 1 inch is defined exactly as 2.54 centimeters. Now, not all of these conversions are going to be exact numbers. You'll be told when those conversions are. But again, any exact number is defined as having infinite significant figures. All right, so having just gone over that, what I'd like you to do is I've got 5 values here. I want you to pause the video lesson here and go through and count up how many significant figures you think that the numbers have. All right, and then once you are finished, hit play again, and we'll go over and we'll see the answer. All right, in the first one, we have these 2 zeros here. These are leading zeros. They indicate only the position of the decimal. They're not significant. The 1 and the 5 are significant, as well as the 0 in between. So this has 3 significant figures. All right, in the second one, again, we've got 2 leading zeros, right? And we have a trailing 0, but this trailing 0 does have a decimal point here. So this one has 5 significant figures. All right, number 3, we have 1, 2, 3, 4 significant figures. It's given in scientific notation, and if we make it a point to put that last 0 on there, if there is a decimal point there, this trailing 0 is going to be significant. All right, if there are 6 students in the class, that's something we can arrive at by counting. So there is an infinite number of significant figures. And the price of gas is $2.09. I can count out 209 pennies exactly, so that's an exact number. It also has infinite significant figures. All right, now when using mathematical operations, how do we calculate the number of sig figs in our answers? For multiplication and division, the number of significant figures in the result is the same as the number in the least precise measurement. So if we were going to multiply 4.56 times 1.4, right? So the calculator is going to spit out 6.38. The issue is that the least precise number only has 2 significant figures, so we should really report our result as 6.4, only having 2 significant figures. All right. For addition and subtraction, the result is going to have the same number of decimal places as the least precise measurement used in the calculation. So let's say I'm going to add up 12.11, 18.0, and 1.013. Right, so put these all in the calculator, I'm going to get 31.123. However, the least precise measurement in my calculation is limited to the tenths place. So the result can also only go to the tenths place. So I'm going to report the number as 31.1. Now when we have to reduce the number of significant figures, that's going to cause us to have to employ rounding. Now, in a series of calculations, carry all the extra digits through to the final result, and then you're going to count up the sig figs and then round. All right. If the digit that is going to be removed is less than a 5, right, then the preceding digit stays the same. All right, so here, 1.33, we already know that this last digit is not significant. We need to remove it. Since the 3 is less than 5, then the preceding digit stays the same. It's going to be 1.3. All right, if it's equal to or greater than 5, the preceding digit is increased by 1. So here, 1.36, we have to get this down to 2 sig figs. So because this digit to be removed is greater than or equal to 5, this is going to round to 1.4. Right, but always carry all your calculations through until the end, and then you're going to round. All right, and so that just kind of goes over some of the fundamentals. A lot of this should be review, but take time to go through some of the stuff in Chapter 0 and make sure you're up to speed on your units, that you know the prefixes, and that you can do sig figs and rounding.